Have you ever wondered what a chemical formula is? How is it different from a chemical compound? And how do you write a chemical formula anyway? Hi, I'm Dr. Ramon and I'll be discussing these three questions today. So let's now address that question. What is a chemical formula? Well, a chemical formula is just a shorthand way of writing down the composition of a chemical compound. A chemical compound, on the other hand, is just a substance, any substance. That's what you call a chemical compound. Not what you need to understand about a chemical compound is that it's always electrically neutral. What I mean by that is if you have water, for example, the formula of water is H2O. Notice that there is nothing written as a superscript after because water is electrically neutral. That means it has zero charge. It has to be composed of 2 hydrogens and 1 oxygen. That's what the subscript really means. And this is what you call a chemical formula. Now, it's important for you to remember that a compound should always obey the law of electron neutrality. Let me write it down. Law of electron neutrality. What that means is that your compound should always be electrically neutral, meaning zero charge. So let's go to the steps in writing the chemical formula. The rule is called Criss-Cross rule, and there are a couple of steps to it. I broke it down for you. The first thing to remember is that you have to write the cation first, followed by the anion. What's a cation? A cation is just a positive charge. An anion is a negative charge. So they're both ions. One is positive, one is negative. You always write the positive before the negative. Let me give you an example of that. If you were to write the formula for the combination of beryllium 2+ and let's say phosphide, this is called phosphide, you always write beryllium first before the phosphorus. Now, the next step is to make sure that the charges are simplified, meaning the magnitudes 2 and 3 has to be in their simplest ratio, and 2:3 is a simplest ratio, so you don't really need to do anything for step 2. In example 2, I'll give you an example where you do need to apply step 2. Now, the third step is to write the subscript of the cation as the magnitude of the anion. So, what does that mean? This is your anion. The magnitude of it is 3. So, I'm going to encircle it. Just the magnitude, doesn't include the sign. That becomes the subscript of beryllium. So, beryllium ends up having a subscript of 3. Step 4 says that the subscript of the anion will be the magnitude of the cation. So, this is the magnitude of the charge of the cation. That becomes the subscript of the anion here. That's the reason why you call it Criss-Cross rule. So at the end of the day, when you do that, then your compound becomes electrically neutral and therefore the charges cancels out. For short, you drop them. And so the final formula that you would have for this compound is Be3P2. Now, let me give you another example. Supposing that you have aluminum 3+ and nitride, that's 3-. So I wrote the aluminum first because it's the cation, and then I followed it up by the nitrogen, which is the anion. Then I'm gonna simplify the charges. The charges are 3 and 3 in terms of magnitude. So I'm just gonna simplify this to the simplest ratio is 1:1, and then I'm gonna apply the Criss-Cross rule. That one there becomes a subscript of the nitrogen. This one here becomes a subscript of aluminum. At the end, you drop the charges. You end up with Al with a subscript of 1, and again, like the charges, if the subscript is 1, you don't have to write it down. It's understood to be 1, and nitrogen will also have a subscript of 1. So that's an example of the Criss-Cross rule. Now, the question is, what if you have a polyatomic ion involved? Let me give you an example of that. You have, let's say, a combination of ammonium 4 with a charge of 1+, combining it with sulfur with a charge of 2-. Now, this ammonium ion is a polyatomic ion. The steps are exactly the same For number 1, you still write ammonium first because it's the cation, and then sulfide you write next because that's the anion. Then you make sure that the charges are in their simplest ratio, and the charge here is 1:2. That's already simplest ratio. This is where you need to pay attention, because when you apply the crisscross rule, what's gonna happen is the 2 here, which is the magnitude of the charge of the anion, will become the subscript of the cation, which is your ammonium, NH4. How do you do that then? Well, when you have a polyatomic ion and you know that they're gonna have a subscript that's greater than 1, which in this case is gonna be true, you have to enclose your ammonium in parentheses first, and then you write the subscript outside. And then you're gonna do the same for the anion. The 1 becomes a subscript of sulfur, and you don't have to write it down. And so at the end, your final formula is gonna be NH4 parenthesis 2S. Let me give you one more example, and then we're gonna be done. Supposing that you have Mg 2 plus, and you want to combine that with OH 1 minus. So if you apply the rules here, I wrote magnesium first, followed by hydroxide. I simplified the charges. In this case, 2:1, you don't have to do anything there. And then you're going to apply the crisscross rule. That would end up having the 2 here become the subscript of OH, and the 1 will become the subscript of magnesium. And because OH will have to have a subscript of 2, then that means you have to enclose it first in parentheses before you place the 2 outside. And so at the end of the day, you will have a formula that is Mg parentheses OH2. So that's all there is to chemical formula writing. Now it's time for you to practice.